in insurance domain. He is a guest lecturer in Great Learning Institute for Data Science and Business Analytics program. So now I invite Mr. Aniket Goel for his talk on the topic data science and its application in insurance industry. Over to you, sir.
Thank you, Salish. Thanks for the introduction. Let me share the screen first. Right. Salish, please confirm if you are able to see the screen and my voice is loud and clear, audible.
Yes, sir, you are very much audible and your screen is also visible, sir.
Thank you. So welcome to this AICTE-ATAL FDP talk. My name is Aniket Goel, and as Salish introduced, I am a technical architect at DXC Technologies. So thank you for having me here with the esteemed faculty, delegate members, and the eminent speakers. I welcome you all. Previous speaker Tushar Kanti shared his knowledge with us, and we are thankful to him too. With my let me start with what is the objective with which I came here. Okay, so my objective for this talk, it is to pass my experience in a layman language as much as possible so that we can get most out of the session. And I strongly hope that you will be able to feel the change that AI brings to our daily life. And thus you will be able to encourage your colleagues, students, relatives to read along, work and study on the things that is going to bring the next revolution. So keep it uptight. Let's make it an interactive session. If you feel anywhere that I am talking about rocket science and you're not able to catch this, yeah, feel free to interrupt me, unmute yourself, ask me to explain it again. But at the end, at the back end, in a very layman language. So let's start with what topics are we going to cover up. So today we will be looking at data science at play that you must have already seen. So I'll not bring in a concept which is you're not familiar with. Let's talk about the things which you are familiar with, and let's interact on terms of how they work, okay, how they play in. We will look at the components of the data science, life cycle of the data science analytics problem, data science project framework, essentials, the data science essentials here, and what is required for one to be a data scientist. Okay, what if you wanted to impart to your students or your friends, like if they are wanted to be on this path, okay, what is the essential things they require? That will be part of essentials, and then a few case studies about the insurance domain. So let's see. Okay, so there are 6 companies mentioned over here. Okay, we must all be familiar with them. In somehow, in few of the cases, we might have used them as well. So the first company is Uber, okay, which is the world's largest taxi company. But do we know that they own no vehicle, right? And this is one of the, like, where did I got from? This is one of the WhatsApp forwards. Okay, so you must have seen it in the past, but let's talk about it, think about it, how they are able to do something which they are doing. Airbnb, the largest accommodation provider, own no real estate. The Facebook, the most popular media provider, like, does it create contents and then send it to you? No, they do not create any content, but they're still the most popular media provider. Okay, another one, Twitter, most important, like the news, the most important news channel is the Twitter right now, the fastest growing news channel. But does it produce any news? No, it doesn't. Instagram, the most valuable photo company, sells no cameras. For example, a Netflix, the fastest growing television network, lays no cable. Or the Alibaba or Amazon, they are the one who are the most valuable retailer in the world, have no inventory. Now, none of these 6 companies existed 20 years ago. What made them so popular? What do you think these 6 companies have in common? Anyone wants to highlight, like, do you think there's something common between these 6 companies? Why are they able to make a transformation in the industry? Anyone, any point you want to highlight? What made these 6 companies so popular? How do they do it? The
A
thing,
new idea, suppose.
yeah. So an innovative idea they put into the play. Excellent. Okay. So what is the idea they are looking for? They do not owe the
Easy accessibility.
accessibility and the customer interaction, the understanding the customers. What these six companies are, they are basically the data companies. Okay, they are understanding, because we're talking about the data science now. Okay, so data is at play. How the data is at play? The Uber understands how many taxis are there, at what location they are, at what location they might be required in next 5 minutes. So instead of just having a data of how many taxis are on the ground, how about taking it up further and understanding in this particular region at this particular time how many taxis are generally booked. So if there are not that many of taxis in that area, let's move the taxis over there, so that once you click or ask for a taxi, it will be there within few minutes. You don't have to wait for it, because they are already predicting. Okay, I'm bringing a new word into the session, which is predicting. They are predicting what do you require and when, and deliver you at that time. Okay, look at this Facebook. There are millions of data, millions of posts coming in. Okay, but how much up one person can consume? They cannot consume the message to Facebook. How cool? Because Facebook understands your liking. They are able to show the content what you like on the first page, and then you just interact with it. It interacts with you. But how they are able to do it? They are able to predict what you like. Look at the Netflix. Okay, you watch movies. You have watched 5 movies, 10 movies. Okay, and then suddenly Netflix start giving you recommendations of saying you might like this movie, and that is on your homepage. How it is able to do it? It understands what you like. Okay, and it understands what you like based on the data they are collecting. So your every click on a Netflix homepage will mean that something you will click something that you like. If you're watching a movie from the beginning to the end, that is recorded as your entry. Okay, that is your liking is being recorded. We will drill down a further onto it. Like, it's not just like if I know you like a particular genre of movies, let's say action movie, then they will start pushing the action movies only to you. I've watched 5 action movies, and there are 200 action movies in the library still left which we have not watched. So I start pushing the movies which are action movies to you. But out of those 200, how do I know which 5 I have to show? Because on the homepage you can show only 5. Okay, so which 5, and even what should be the order of those movies to be displayed? They are all data driven. Okay, understanding their customers, and that thing about another disruption which I have not mentioned over here. But do you know one of the industry which was airlines industry? Okay, in airlines industry was like one of the to the airlines industry. Is it another competitor within the airlines field? Let's say a SpiceJet came in, or then the Jet Airways came in with the cheaper prices. No, that is not the place where the disruption starts. The disruption to the airlines industry began with the coming up of video conferencing. So the description to the airlines industry. For example, for this particular session, okay, think about there are few speakers from the abroad. What would be the scenario 20-30 years back? Vikas would have called them, asked them, given them a shiny airline ticket to come to India in front of you and speak. But now what he's doing, he's just sending a link to them, and they are here with you. So that is a disruption to and a loss of business to the airlines industry. How about camera industries? So there was Canon. Okay, there was disrupted by who? A Nokia mobile company. You think previously people used to buy cameras, okay, as in like a special gadget for them. But when nobody got it, so once something is distributed on the mass, it brings the disruption. But is it the disruption to that particular industry? Not necessary. Do you look for the competitor within your industry? Not necessary. There might be somebody outside the industry might come in, and your presence has been done by the Airbnb or OYO in our case. In the industrial revolution. So in the first industrial revolution, we saw that steam-based machines were created in the 18th century. Then the second industrial revolution came in around 19th, 20th century, where the electrical energy-based mass production Okay, computer and internet brought in. Now we are on the verge of a fourth industrial revolution, where this AI, information technology, big data, IoT, cloud, these are the jargon or the see buzzwords you must be hearing around. Okay, you must be seeing that they are in play, but I do not understand them exactly. Like what does they actually do, how they do it, right? So we should be ready for it. So are we ready for it? If we are not by now, we will be ready by the end of the session. At least we will understand what they do and how they do. Let's take a few more examples from our daily life. So one of the example would be the recommendation applications. Okay, so recommendation applications like Amazon recommending you that you might like this product. Okay, so you go to the Amazon, you buy a product, and then they start saying, okay, you might like this product, and you feel, okay, yeah, how do they know that I wanted to buy this product? And you add it to the cart, buy it eventually. Or let's say YouTube autoplay, you just play one video and it starts playing it for you, one after the other, and like I believe personally, YouTube understands me and do not start giving me video suggestions or videos which I do not like. Maybe I would skip one or two, but most of them I would view. So how does they do it? Now let's drill down a little bit more on the recommendation applications and think about it, how the recommendation happens. So when I started by saying from the Netflix, you go to the Netflix, watch videos and tell them what you're liking are by watching. Okay, so they might not ask you directly that, okay, you like this movie or not, or what kind of movies do you like so that I can suggest you. But they monitor you, they see what you do. And then there are other customers also, they are doing it. For the other customers also, there are millions of customers. All these million of customers and the information from them can be read, can be understood alone in the world. If I'm watching these set of videos, if I'm buying these set of items, I'm not alone in the world. There are many other people like me, right? So why not? Hybrid. Right, sorry for the disruption. So how do they know it? Okay, so they understand my behavior. They know that I am not alone in the world. Now find out who is similar to me in the world. Who other people also watches the same thing, also buys the same thing, right? And there will be not one or two, there will be thousands and thousands of people who will be having a similar behavior. So their behaviors are understood, studied, and based on their behaviors, the distance or the connection between two customers are calculated. Once the connections is built, okay, now the recommendation is easy. That is, right at this moment, there are other people who are in the same liking, same behavior like me and what they are watching. Not everybody is using auto, but they want to buy something, they are adding it. Now they are doing it manually, and Amazon or YouTube is capturing that information, passing it on to me to say that you will also like this thing, because other people who have the same behavior are doing the exact similar thing right now. So maybe a bigger picture is I'm able to transfer a daily grocery shop, okay, and you buy milk. Now, what is the probability that a person is buying a milk will also buy a bread? Maybe a pretty high, looking at the historical data of like grocery store. If he understands his customers, if he understands customer, he say whenever Mr. Aniket came to the shop to buy a milk, he also buys a bread. So why not next time I buy some milk and forgets to put up a bread into my basket, he tells me, sir, you're not buying a bread now. That is what this Amazon is doing to us. Okay, customized recommendations. Think about it, there are millions and billions of customers, and it is able to process it, transfer that information as a like personalized information. The grocery store outside my building might know me personally, and he may be interacting with me personally, and that is the same kind of interaction I'm getting from these websites, right? So that is what the data at backend is at play. So everything is about data. Okay, data is the gold. We will look into it in a little deeper sense how the data can be set as a gold, but let's talk about what the business analytics does. Okay, what is the definition given to it as a formula? So Mr. Thomas H. Davenport gave a definition to business analytics. Okay, so it says business analytics can be defined as a broad use of data and quantitative analysis for decision making within organization. Okay, so organization can be anything. So the normal words I have not bolded, but I've bolded data, quantitative, decision making. So there are three things. You cannot just have a data, okay, which was like 20 years before. You have got internet, there's a lot of data. People are posting, like there was a website called Orkut. Okay, so people started posting on Orkut. There are other places like blogs or news portals. Data has been collected from ages. So just not about the data. So data is there, but what to do next? Bring the quantitative analysis. So analysis has to be done, but that to be quantitative. That has to be numbered. Okay, if you say that Aniket is going to watch this as a next video or buy this item as a next item, what is the probability of Aniket to buy this item? Or the probability of Aniket to watch this video? Right. So because if let's say I understand my customers, I understand that they might buy it, but there has to be some decision finally. Okay. And this decision is the part where the artificial intelligence comes into the play. So when you hear somebody saying, okay, this is very artificial intelligence, okay, it is intelligent. How can somebody becomes intelligent? They becomes intelligent because once somebody or a machine is able to process something and then make a decision out of it. So humans are intelligent because we are not just seeing something, okay, we are making some decisions out of it as well. That is why we become intelligent. We are said to be intelligent. Now, are the machines intelligent? Till now, a few years back, the machines weren't intelligent, right? So you will be able to browse the internet, okay, you were able to search a lot of things in the internet, do your day-to-day working on the internet, maybe storing files, making presentations. So the data was there. It has been processed, but there was no decision making by the machine itself. Okay, where does the decision making comes in? Okay, let's see. One of the decision making, which as an example we have just saw, is about recommend this out again a little further, but talk about the data quantitative part and decision making. So without decision, nothing is intelligent, and we have to reach to a goal where a particular decision is making. Okay, so like example, Tushar talked about previously, which is about imaging. Okay, so electrical equipment has been built, which is to understand the human body. Okay, our imaging system is there, but that is the part where the data can be collected. Now, how does data tells you is there any problem in the human body or not? Okay, it's very complex in terms of, because every human being is different. Their imaging artifact will be different. So if you look at MRI results from myself to the other person, there will be a vast, huge difference. Okay, a lot of experienced knowledge or a doctor's information is required. But do a data scientist require all that? Yes, in terms of making machine learn, it will be required. But once machine learns something, it will be able to directly process it, and not only process it, make a decision to say, do you have a problem in your body or not? So the word saying a problem is there or not a problem there, classifying the MRI output as a problematic or not problematic is the intelligent part. Okay, that is the last bit which actually makes it intelligent, and that is what we are aiming for. So what makes one data scientist? Okay, so as I start, like just now I made an example of saying an experienced medical professional is required to understand the MRI. Okay, Aniket Goel do not understand it. Okay, but can Aniket Goel become a data scientist in that field without knowing it? No, it would not be possible. Okay, and where do I believe you fits best? Okay, on this data science complete procedure. So let's think about it in these three bubbles, which looks at as solo. Okay, we start with this. Statistics or mathematics is a region where, like in class 11, 12, okay, or in your engineering phases, you must have seen mathematics at play. Okay, you have understood that there's differential integration is being done. Now, how they are actually used? Okay, the implementation part. So at a solo, what you can do is you can create advanced mathematics. Okay, experimental designs, model fitting can be done. So these are the parts which a statistician play. Okay, the knowledge of a statistician or mathematician plays this particular part. Then let's come to this hacking or coding part. Okay, where one of the computer developers or somebody who has not what they at a solo do, they can prepare the data like data collection. Okay, so you, if like say MRI is to be scanned, so when MRI is done, okay, that is in terms of imaging. Okay, image has to be stored, so data has to be processed, so data preparation is to be collected, which is that some developer is doing it. Then there comes to a data governance. Okay, so data is secure, so data cannot be passed on easily. Your data is your gold, you do not share your gold with anyone else. So that governance, who can view my data, which part of the data can be exposed to the outside world, that is all the being controlled by these hackers or the coders. How do they process it? They use SQL queries, which is something like how do you communicate to the database using some scripting languages. Then the third part comes in, okay, where I believe every electrical engineer fits the best. That is the expertise, understanding the business. And in a few slides, we'll be talking about how we can bring the data science to any field. Okay, data science is not about computers. When we talked about data science was at play for the taxi company, data science was a play for a television network, okay, or a retailer. Happens when something is being amalgamated with other industries. Cross-border activity happens, then only something as a result becomes as a revolution. Now here as a expertise, what the best you can do, which nobody else can do, is you can translate to non-technical audience. So there are technical terms in your industry, in your engineering, which I do not understand, but you can translate that to another person or to yourself. You can understand your customers better other than anybody else. You can define the metrics that matters. So by metrics, we mean, let's say that data has to be played. Okay, so data has to be played around something, out of the data has to be extracted. Now what data? So think about it. Okay, let me bring a new phrase over here, which is machine is something which is ready to eat. Okay, and we have to feed it. We have to feed the food to machine. Now who will cook that food? You cannot put uncooked food to machine and to eat and then to bring the energy out of it. You have to cook the food. So who can cook it? You as an expertise in your industry will be able to cook the right amount of food for the machine to understand. And we will talk about that food later on. Like, do not think that it's over. The food will come along again. But that is the metrics. The food that has to be fed to the machine is the best which you can define. You can ask the good questions. Okay, you can talk about something is happening, how it is happening. Make it actionable. Once something has been resulted out of the learning done, the information is collected, but how to make it actually applicable? That is the actionable part, which expertise in the industry or the basically any industry. Let's say as a hotel industry or a taxi industry, the people who are already knowledgeable about it will be required to pass on that information and bring this whole data scientist circle into play. So a statistician who has also got a knowledge of expertise in that field, they can create some statistical packages, which is the traditional. What type of analysis was done? Was there no analysis done? No, the world was with the analysis. The analysis was there, but that is a traditional type of analysis. The research was on the topics they are also familiar with, the industry which they are expertised in. That is traditional research. How about data engineers? So data engineers is a kind of a new term coming into the industry, talking about they are like I'm a data engineer. So what does they do? Okay, they have the business knowledge and they have the coding knowledge. So they can transform the data, they can turn the data in the way they like. So get the right data is the part the data engineers play. Now, where does this machine learning comes play? Okay, so once the mathematics is attached with the coding, that is the part where the machine learning comes into the play. So a person who has got a knowledge of coding and understands the mathematics can bring that together, amalgamate it into the machine learning. And this machine learning, data engineer, traditional researchers, all this together, okay, not one or two, but all together brings the data science information out. One thing I missed, which is about the predictive analysis or scriptive language. This is about like when the machine learners, what does they do? Okay, they do predictive analysis, as I said, predicting what you like. Okay, predicting anything, like predicting about like if I want to if I want to predict what is a salary of a person. Okay, let's say I will pass out from this engineering college. What will be my first salary if I wanted to predict that? Okay, so prediction part of that. And we will take it as a more further examples in the next slide. So by now we are in a position to say, okay, there is some data analytics problem. Okay, so there will be something related to data we have to do. Okay, then how does it actually work? Okay, what is the life cycle of this data analytics problem? Where does it start from? So it always starts from problem identification. Okay, so let's say from the MRI scanning part. Okay, so there was a problem. The problem was that the MRI were very complex for a human mind to actually pinpoint. Okay, even very seasonal doctors might miss few points from the MRI scan. They are very complex, very I would say unique from person to person, and got lot of complexity. Okay, lot of researchers faces a lot of challenge to it. So that is a problem. Okay, there is a challenge being faced by people that it is complex to be read by the naked eyes. The problem is identified. What to do next? Form some hypothesis. Okay, hypothesis would be looking at this image, which part actually causes a problem. Okay, is there a tumor in the head? How to find that tumor? Okay, is there a relationship between some particular image pattern and the output, which is the person has got a tumor or not? Okay, so now I'm bringing few things, which is the factors. Okay, what in the image is constituting the result? The result being a person has got a tumor or not. So a hypothesis has to be formed. Okay, this actually matters, and a part of the image, does it matter to say a person has got something? That is hypothesis formation. Once the hypothesis is formed, a data has to be gathered. Once millions of MRIs or billions of MRIs are stored, gathered, then the processing begins on them. The analysis begins on them. The analysis with the focus to prove a hypothesis. Okay, hypothesis is an assumption. We are assuming to begin, like we started by saying there's a problem that the complexity of the MRI scan has to be identified. Now we started by saying, okay, we can do it by a hypothesis that this is the area we will be concerning about, this is the other area we will be concerned about, and try to understand how this image can transform into a final signal to say it's a tumor or not. So data analysis comes into the play for proving or disproving this hypothesis at the back. And then finally, if we are able to prove the hypothesis that it's right, okay, we are able to found that looking at the MRI image, we can say a person has got a problem, then that is to be implemented. That is the last part, the artificial intelligence part, default. 10% probability to default, I see it's a good person, I'll give in offers. Okay, if it's 60%, 80% probability to default, I strategize myself, I play around the different factors. So either I do not want to give him a loan, or if I wanted to give him a loan on a tighter conditions I wanted to give him. So yes, that is the way the industry works. Right. Moving to the project framework. So how does this data actually process? Okay, what happens in at a different stages? Okay, or let's say where are we right now? So look at this x-axis on the. So as the y-axis increases, okay, the difficulty increases, the value output for the business. So value in terms of how much it is valuable for the business. This particular analysis is valuable to the business comes out. So difficulty increases, value increases. Okay, so it's on the positive correlation going up. So things start from what happened. Okay, so let's take an example of education analytics. Okay, so you have got a student in your class, okay, and you are studying a lot of students. So from the past information, okay, you are trying to analyze. When you interact with somebody, your mind already started interacting, knowingly, unknowingly started interacting, started collecting the information, processing it, okay, understanding what happened to this person. So this person was performing like this in the last 6 months, and then finally outcome I've seen for this person. So understanding what happened with a particular subject is the descriptive analytics. We describe what has happened. That is what most of the industry is ready to do. Okay, if somebody is creating a report, if you're creating a report for your college, that is the descriptive analytics. Okay, how many students have you got? How many students are passing? How many students failing? How many students scoring in this bracket? All is descriptive analytics. Diagnostic analytics becomes why did it happen? Okay, so in a particular subject, okay, let's say semester 3 of subject electrical science, people are scoring less. Okay, now why did they score less? Okay, what happened in it? Okay, what made them score less? Maybe the paper was hard, paper was low, people were not attentive, the subject was not taught properly, the students were not attentive. So there may be n number of factors. So all those factors which we collected previously, what happened to my data, is now going to be used for why did it happen. Answer for that gives us a relationship to prove that hypothesis of saying, is this factor actually constituting to the output? The output being in this case is people like the performance of the students are good or not good. Now, we at this stage are at this stage we are at a position where we can say we understand the data. We know what is the relationship of these inputs, okay, being studying the past historical subjects, the students, and then relating it to the output, passing or failing of the output or performance of the batch. Now, once we understand this, okay, next time before the exams, okay, we will have the information how the current batch is performing. We put that into the machine back, okay, we feed it back, and then we find out the output. That is, we are predicting what will happen at the end of the semester. So during the semester, we are able to highlight what is going to be the end of the semester. That is predictive analytics. We are predicting it, what will happen. Okay, and then we are not going to stop over there, right? We are going to prescribe, like the doctors prescribe you the medicines, okay, to make your pain go away. So there is a pain. My batch is not going to perform well. So I have to make some changes to the business, the changes which are under my control. Okay, so not everything I can change, all the factors I cannot change, but I can play around. So there will be some factors which are related to the output and which are under my control. So I just move the switch up or down for that particular factor. That is going to be the prescriptive analytics. What to change, how much to change, so that the output is in my favor. And that is the journey of difficulty from descriptive to prescriptive and the value it gives. The data science can be thought about the collection of all this. The AI part starts from where the diagnostic starts. Okay, and it actually AI is the one where the prescriptive goes in. Okay, and in the another example, like basically another depiction of the same information, which I'll quickly cover up. Look at this particular part over here, which is the human input. Okay, because like we are very much interested in AI part. Okay? We wanted to see what the AI is doing. Okay, so it's not a rocket science the AI is doing. It's about the human input has to be reduced. Okay, so it's something somebody is understanding something and automatically doing it for us. Okay, it's not asking me to do. So previously some decisions has to be made, which is descriptive analytics is done. Okay, let's say you created a report for your batch, provided it to your dean, and then dean looks at it. Okay, he talks with you. A lot of human interaction happens over there. You go to the students, you talk with the students, and then a lot of interactions happening, and then finally some decisions are being made. So a lot of, you see the light blue color, a lot bigger light blue color is there when we go only with the descriptive analytics. When we go with the diagnostic analytics, we are a little closer to the decision. Predictive, further closer. And then when it comes to the prescriptive part, okay, we can support the decision or we can automate that decision. If we are supporting the decision, that's going to the decision part over here. And if we are automating it, that is completely a AI in play, that is action over here. Right? So this is where the AI comes at the end to the play. Now coming to the part of like all this thing we understand, okay, there are factors coming into the play. We have to find out those factors. We have to cook that food for the machine. Okay, how do we cook it? Okay, so what is a data scientist role, a day-to-day experience of a data scientist? Okay, how does they cook that food for the machine? So what they start with is going to the business. Okay, the expertise business part I talked about. So they go to the business, they talk about the business and ask lot of questions. Okay, lot of questions about what is the problem. Okay, understand the problem, understand what the objective of the study should be, what the end goal they wanted to achieve, okay, and how their business currently works. Once this part is understood, okay, they go back to their desk, which is over here. If you can see my mouse, a person comes back and then the data acquisition starts. Okay, so now they understand the business works, where is the data for the business, and they start collecting the data. Okay, the data, which is the food, I said. So the crop has to be cut and brought to the warehouse. So crop is being cut, brought to the warehouse over here as a data acquisition part. Then जैसे धान की सफाई करते हैं ना, ऐसे डेटा को भी क्लीन करना होगा. Okay, so there will be lot of discrepancies in the data. There will be lot of misinformation provided in the data already existing. So like not somebody provided it intentionally, but this is how the data has been collected. Okay, so we have to clean the data. Okay, we have to transform the data. Cleaning part has to be done. This is where the food is trying to be cooked. Okay, once the food is cooked, the exploratory data analysis to be. Exploratory data analysis is this descriptive part. Okay, once we are able to describe, so we cannot go directly to this decision making or the prescriptive analytics. We have to go step by step. So the first step is over here. Okay, data analytics, which is data analysis in terms of how do I shape my data. Okay, how much do I understand from my data. Then it comes to the model building part, where we try to make the models. So historical data is there, put it to the machine and let machine bring out the insights out of it. Okay, and those are called models. Model can be thought about like a prototype. Okay, you create a prototype. That is how we create a model into the business of data analytics. We create a model to say, looking at the historical data, my machine has learned something. Okay, let's prove it. Okay, so we prove it. Okay, we go and start feeding new data to it and see how well it is predicting. So once we are sure that prototype is working, okay, we take it into the production. So this model's data has to be communicated well back to this person, then the business owners. And when these business owners are satisfied with this understanding of the level of processing we have done, the level of prediction has been done. See, nobody can predict 100%. Okay, so 100% prediction is a myth. Nobody can do it. Okay, but how closer we are, how much satisfied we can make a customer. Okay, customer can be satisfied. Like few industry customers are okay to have it with 70% probability or 70% confidence. We are able to predict something. Okay, they are happy with it. Okay, think about it for a share market. If you are able to, like currently, without any analytics being done, okay, if you just have to guess, the share price will go up or down. Okay, that is a pure plain guess. Okay, that will be 50% probability. A share can go up or can go down, right? 50% probability at a play. Now, if you can increase this 50% of probability into your favor by only 5%, okay, that will be making you billions. Okay, you don't have to predict something with 99% accuracy. You have to predict stock market with 5% extra accuracy. With 55% confidence, if you bring out the prediction of the stock market, you will earn billions, right? You can just make money out of it. So there will be industries which are okay with 55% accuracy. They will be okay with 95% accuracy, and they will be requiring 99% accuracy. Okay, so that is all being governed by. When we do study, okay, the analysis at the back end, we take confidence intervals, different factors, the errors which can be possible, how much confident we are. So all those are being taken into account, so that when we come to a conclusion, we will have a number to say that how much confident we are. Okay, so confidence comes into the number saying, if you have got 1,000 loan applications at your desk, okay, and we are automating it, and we are saying a person will default. Okay, so do not give a loan to that person. And if we are saying that, so we are saying it with how much confidence. So out of 1,000 files, we will tell that person will default or not, but we will be 990 times right. 10 times we might say the person will default, but he actually do not default, or we can say he will not default and he actually goes default. So 10% time, so not 10%, 10 number of times out of 1000, for 10 customers we might be wrong, but 990 customers we will be right. That is the interaction or the level of confidence we used to pass to the business. Once this is on play, we deploy it and look at the intelligent part of it into the play. Right. So I think I've talked a lot. I wanted you to feel the change that the data science could bring to the daily lives. Okay. And see, we've talked a lot about what is being changed at the back end. Okay. So how we are doing, it's fine. Okay. What is the outcome we are looking for? How it's changing the lives? Okay. That is what this video will tell you. So I'm playing it, and it will be not a longer one, 2 or 3 minutes. Please watch it and feel the change. I'll tell you. So this is about a video where application has been built. Yes. Are you able to hear me? Okay. Maybe the sound being transferred, but let me give a short brief what this video was about. So this video was trying to depict a scenario or application to be built for people who are not able to see, but they can interact, they can hear. Okay, so the mobile or the handheld device they have got, it can talk. Okay, so AI can read what is in the image. So you share an image to a person, you post something on a Facebook, and for a person who's not able to see it, okay, what kind of change or smile it brings to a person when they understands like the image has been shared and what is in the image. Okay, a image of a child, the weather, how it is look like, the background, what is there, who are in the image, and when this is talking with a person. Okay, think about See, for us, it will be very normal to have such kind of information in our like mind. Okay, but passing on the information for those people is extremely impossible previously, which is being made possible by the artificial intelligence. That was like a summary of this. Sorry about the audio not being transferred to you guys. Maybe when I share the presentation, you might want to see it again, and then the audio will be there. Right, coming back to the normal slides. So over here, I think there's some echo coming in. Can you mute? Let me try to see. Right. So again, I wanted you to please unmute yourself and tell me. Everybody has got toddlers in their house, of seeing the toddlers, try to taught them. But how do you teach a toddler to differentiate between a boy and a girl? How do you teach it? Because see, now we are talking about the machine learning. How do we teach the machine? Okay, machine is a toddler, it doesn't know it. Okay, he like machine can save lot of images. Okay? It can save lot of images, but it doesn't know what inside the image is, which is the same thing which a person can see. A toddler can see lot of people around, but they do not know what is it. Okay, how to differentiate between an apple and an orange? How do we teach a toddler this is an apple or this is an orange? Okay, how does he learn it? Can you give me some pointers? How do you differentiate? Let's talk about how do you differentiate. If you see a person, how can you say this is a girl or this is a boy? Come on, I'm sure like a lot of you can actually differentiate between a girl and a boy, right? You can do it, but do you know how do you do it? Don't be hesitant, unmute yourself, guys. Any pointer would be nice.
Because of the babies are having the different dress here.
Excellent.
Girl babies.
So yeah, excellent point brought, which is a dress. Okay, so based on the dress, you differentiate between a girl and a boy. So looking at the way they are wearing, right? What else?
And the both of the girl babies are having a good amount of hair on their head.
Looking at the hair, we differentiate. So we as a human differentiate between a girl and boy by looking dress, hair, maybe eye shape, eyebrows, lip size, right? The shape of the nose, skin tone. So what are these? The words which I just talked about. These are the factors. Okay, these are the informative inputs which we take into our brain, and then the output from the brain comes out and say this is a girl and this is a boy. Right? So this is something which we can imagine. Okay, we can take inputs and then we give an output. But what happens between this input and output? What happens when we have taken, like I saw that, okay, this is a dress. Okay, this is the eyes shape. This is the eyebrow shape. Okay, how much makeup has been done. All those things I take as an input into my head, and then there's some processing happens in my head, right? That processing is the one which is what we wanted to pass on to the machine. So instead of happening that processing into my head, I want that to happen in the machine, so that machine can also give that output which my head gives me. Right? Isn't that be an intelligent area? And isn't that what you see on the Google photos, on the Facebook? Okay, it all started from a point where you upload something on a Facebook and Facebook asks you, okay, do you want to tag somebody? Is there somebody you wanted to tag? So what you do, okay, I want to tag. So you click on a face and then tells who is this face. Okay, you write it. You tell the machine at the backend what is happening. You're telling the machine that this is Aniket Goel. Okay, this is Aniket Goel. So there are thousands of images of Aniket Goel, and you're saying that this is Aniket Goel, this is Aniket Goel. So machine is being again and again told this is Aniket Goel, and that is how machine learns. This is Aniket Goel, right? Now, the learning part, okay, let's dig a little deeper onto that part. How does that learning plays into picture is, when we said that this is the dress, okay, looking at the dress or the eyebrow or the nose shape, do you think somebody will be writing a code because the machine works on instructions. So you give an instruction to the machine and say, see, if you look at this particular color of dress, then give me the output as it's a girl. Okay, this color of dress is mostly worn by men, so it is a man. Okay, this is the type of hairs girls have, so this is, so you tell the machine that this is the characteristic of that factor, right? And then the machine will be able to do it. That is, you write a code for it, and then the machine does whatever you have instructed him to do, right? But imagine how many colors of clothes can be there, how many eye shapes can be there, how many skin tones can be there, how many hairstyles can be there. Will anybody in the world be able to write all those instructions to the machine? Right? We started by talking about like MRI scans. I said that every person has got a unique MRI scans. Within the MRI scans, there are so many imaging technologies, so many images that it is like impossible to even read by a normal human being. Okay, how do I write a code for it to tell the machine that look at this particular part, and then because this particular part will look this much of darker, so you say something as an output. That is now how it is possible. Okay, so it's impossible on that area. Even you hesitated to tell me as a business understanding. You understand this business, okay? You understand how the boy and girl is being differentiated, but you're not able to communicate it to easily to the world. So how will a coder be given an instruction to write something? Okay, I think some hands has been put up by Mr. Kumar. So yeah, please go on. And no, okay. So how do we teach the toddler now? So we do not tell a toddler that because see, baby, this person is wearing this color of dress. So what we do instead, right? We instead just point out to a person. Okay, I point out to my baby. I teach my baby saying, look a girl, look a boy. Okay, I show them multiple images and tell this is a boy, this is a girl, and there is something happening in his head, in his brain, the toddler's brain. That is, looking at these images, there are features which the features they are capturing. Okay, the features which we just talked about are those features, but we are not telling the features specifically. We are not teaching those features specifically. Instead, we are showing them multiple examples and saying that this is a boy, this is a girl, this is a boy, this is a girl. And sometimes we are not like toddlers might not be super intelligent to just say, okay, you have told me for 3 or 10 images or 10 people have shown me these are boys and girls, and now I learned it. Maybe they will do it wrong next time. Okay, that's okay. Like we say, okay, no, but we correct them. So next time they say a girl as a boy, we say, no, this is a girl. So he will again have another example, specific example to try to distinguish why is it girl? What is it in my machine? Like up till now, I've got something in my head to say girl, differentiate between girl and boy. Now a new example is coming up, which is I'm giving an output as a wrong output. What is now differentiable? Right? So I have to recalculate my brain. The toddler has to recalculate the brain and then fit in a new image into it. So the classification of boy and a girl is a continuous process that will keep on going in, and after some time you will see that flawlessly is able to classify a boy versus a girl. And that is how this Facebook or the Google photos evolved. So you started teaching them, this is Aniket, this is Aniket, this is Aniket. Okay, after some time they made mistake. Okay, they suggested you that Aniket is in this picture, do you want to tag him? Okay, then you said no, Aniket is not there. You again taught them, and now they are so proficient, they are so much confident in the predicting power they have done it. You can directly search for Aniket Goel in millions of photographs on your device, and they will just pull it out. Okay, even from the mirror images, they will be able to find it out. I am somewhere in the background in a crowded place, and they will be able to pick my image and show you, okay, in this particular image, Aniket Goel is there. So over the period of time, this learning happens. And that is what we are moving towards, that revolution. So it begins. A toddler might take 3 years to walk. Okay, but from 3 to 4 years, he starts running. and after 4 years he's not stopping, right? That is what the machine is also doing. We are feeding the food, we are feeding the data, okay, we are feeding the images, we are telling the machine this is boy, this is girl, and at the output of it, machine is learning, which is learning slowly at the moment. In few industries it has actually evolved well as well, but if it is not evolved in some of the industries, it will evolve. Okay, the revolution happens when one field interacts with every other fields. I give you example of multiple fields, and you can imagine, like personally I cannot imagine any field where the data science has not brought up something into revolutionizing in that particular field. Okay, be it medical science, be it sports, financial business, industrial. Yes, you are.
Sir, actually, before you told in credit card risk management, there is an example. So out of 100, if there are 100 customers, out of 100 customers, it is predicting 90 customers as correct and 10 customers as incorrect. So let us take, sir, am I audible, sir? Sir?
Yeah. Yes, you are audible. I'm hearing
you. Yeah. So in that scenario, let us take healthcare domain. So I would like to predict a patient is having any kind of a brain tumor or not. In that scenario, if my model is predicting, for example, if there are 100 patients, I'm going to train 100 patients. I'm giving 100 patient data samples. Incorrect means then automatically the rest of the people are going to die, right? If it doesn't give good prediction. In that scenario, how my machine learning or deep learning algorithm is going to handle?
Yes, so I think a very good question. Now here it comes to that when we are saying that we are not 100% correct anyways, and people are going to die, what we have to do is there is a type of error. Okay, so the errors are under our control. So let's say let's take an example which is right now working into the world, which is about corona. Okay, so there is a corona patient. And I say that we can control the errors. Okay, we can control the errors by saying you do a test, and let's say oximeter. Okay, so for the oximeter test, which I think most of us know that it should be, the values of the oximeter should be above 90. Okay, and then above 90 it is, then you might be okay. But if it is below 90, then there is a concern. You need to talk to the doctor, right? That 90 number, how do you think that 90 number came in? Why not 95? Because generally 95 and above is a good oximeter number. But why this 90? See, what they wanted to do.
Threshold.
Sorry?
It is a threshold, sir. So for example, if you go for
that threshold is the business. So the threshold is put into the business by somebody to make sure that even if more people come to the hospital, that is okay. Right? Threshold could be put up as 85 also. Or 80
by default, if you go for logistic regression or any kind of algorithm, by default 0.5. I can override it to 0.9. For example, if the problem statement is healthcare, I would not be giving only 50% of confidence. So if my model is predicting only 50%, in that scenario, I'm going to lose my customer or lose my patient. So I would like to protect them. So I might be putting 0.95 by using AUC and ROC curve. I will be plotting all these curves with respect to my model. But I want 100%. My true negative rate should be 0, sir, in healthcare. I mean, if a patient is having corona, then automatically it should predict correct. But the vice versa chance may be okay, but the patient should be predicted correctly if he is having COVID or any kind of disease.
So over there, we actually reduces the threshold to say even if person has got a slight hint of probability of having a corona, we will include them. So instead of having 50% of probability to say if a person has got 50% or more probability to say they have got corona, then we will reduce the threshold to bring out to 5%. Even if a person is showing 5% probability to be a corona patient, we will mark them as corona so that he can take a precaution. He do not go around and walk around and then produce more corona patients. So that is where we wanted to reduce it. But to say that we will bring it to 0, that would be a task which I would say is impossible. So do not go on that particular part to say we will do it 0. You may be able to do it 0 for a small sample of data which you are working upon, but not to generalize it. Okay, a constant, a stable model which can be generalized to the public is much more effective than a one which you are working on a solo. So always look for something which is, you can play around with the thresholds to bring in more patient or less patient, but that has to be business driven, looking at what type of business you are. So as you rightly pointed out, in the medical sciences, even if person has got a slightly hint of cancer or any medical problem, we should be highlighting them. Okay, we should not ignore it, because ignorance means the person will go happy, will not take problem to it.
Yes,
If
yes.
it has got a, let's take in precaution. So taking a precaution is better than cure. So
Yes,
that
yes.
that is to be taken in account in terms of threshold playing.
Okay, okay. Yes, I got your point. Yes. Thank you, sir.
Right. So let's take this. How do we teach toddlers and then how do we teach machines? So we talked about it by saying traditionally we used to code something. We have to tell the machine that if this is the color, then please give me the result that is a girl, or if this is the color or this is the shape of the body, then tell me that this is a boy. Okay, so input is that image. Okay, we pass that image to the machine and there's a code, a traditional rule-based coding being done in the machine, and then the results comes out. Okay, which is transformed, which is completely changed because we saw there is a restriction. We cannot do this particular part, coding part over here. So we do not do it. Who will do it? Machine will do it, where the machine learning comes into the play. So what we will do it, we will not write the code. We will give the historical data, a well-cooked food, a gold information to the machine, and let machine do the analysis on this historical data, which let's, in our case example, images of boys and girls. So we give them thousands and 10,000s of images of boys and then 10,000 of images of girls. Let the machine learn it and then produce the code. This code will go back into the traditional way of coding, put it into here. Next part will be let a new image comes in. The machine will look into it based on the code which machine itself has produced, looking at the historical data, and then produce the result. This is how the machine learning comes into play. Now, you must be imagining, okay, how can machine create a code, right? So let's talk about it not too deeper because I do not want to go into the algorithm part, but I wanted to go with something which is like, I said the machine is able to create a code for us. How does it do it? Okay, so a simple example could be the very basic neural network perceptron. Okay, so this is kind of a cell. So a particular one cell in your body brain, okay, you can think about it, and there are billions of cells in your body. So one cell, I'm explaining how we are trying to mimic that particular cell, and then if we create a bigger network out of it, it can learn actually anything. A proper network put into the place can learn unimaginably anything. Now, how does this network works? Okay, so these are the x1, x2, xn, which we are talked about as like inputs. Okay, like we talked about as inputs being these are the particular factors. Okay, person, how much he is earning. Okay, how much he is taking home, how much he is spending, how much child he have got, does he has got house or not, he has got a car or not. So all these are the like the inputs which you basically provides in any form to a business, or from the image. Look at what the image is. Image is a collection of pixels. Okay, each pixel have got some information around it. So you see this particular image over here. You can imagine this at this particular point. Okay, there will be a pixel and there will be value for that pixel. So that value of the pixel is the input or basically the food for the machine to be taught about. So that pixel information will be this x1. Now this information when pushed into the machine, in this perceptron, we say the output would be, okay, on the right hand side, we have got an output. The output would be a function of something. Okay, a function of what? A function of summation, basically a cross product of the weights. Okay, on each input will constitute some weight. That weight will be multiplied. So basically, weights taken inside, done the summation of it, adding some bias to it, and this becomes the input for a function. The function of this particular equation is the output result. Okay, so we will just like give you a quick example of it. Like how do you perceive it if you have not seen the neural network at play in the past? And I'm sure you must have seen the AND gate and so NAND gate, which is the universal logic gate. So you like there was a saying that you can create any circuit using the NAND gate. So let's start with the NAND gate only. Okay, so with the NAND gate, we wanted to create the NAND gate. So what the NAND gate does, it takes the inputs and produce some output. Okay, how about we make this particular one perceptron learn this NAND gate and behave similarly to the NAND gate. Okay, can we make machine learn the NAND gates so that you give this 0 0 as an input and it will produce the output as 0 for you. Oh, sorry, output as 1 for you. And when you give the input as 1 1, it gives you the output as 0. So over here, what we will do is sorry. So what we have taken is that like there are two inputs. Okay. Similarly, in the previous image, we saw x1, x2, xn. So these are whatever the input is coming is, we will multiply that weighted average we have to take. We will multiply it by -1 and -1. We will add a bias to it as 2. Okay. And put up this which is b plus summation of xi wi for I1 to n, which is in our case n is 2. You have got two inputs. So that function will be working out and then the output is produced, which is the out over here. Okay. What is the function? The function can be a linear or non-linear function. I do not go into the complexity of that particular part, but what I try to say is a function is a step function over here is the function will produce an output as 0 when the value, okay, whenever the value which we are passing inside the function is less than 0. If the value which we are passing to the function is greater than 0, the output will be 1. So we have got two types of output, 1 or 0. Okay, so therefore finally the two outputs will be there, 0 or 1. Let's do one calculation for 0, 0 and then for 1, 1. See if it is working or not. So if I put 0, 0 as an input, 0 multiplied by -1 plus 0 multiplied by -1 all becomes 0 plus the bias, which is 2. So the result becomes 2. So 2 goes into the function, and when 2 goes into the function, the output comes out as 1, right? Now the other thing 1, 1. When I put 1, 1, it becomes -2 -2 plus 2, which is all goes into the function as 0. 0 of goes into the function becomes the output as 0. So yes, this particular circuit over here, okay, which I'm talking circuit, but it's basically a perceptron, which is basically able to mimic the NAND gate. Okay. Now where is this learning? What is the learning part of it? We said that okay, machine is able to learn. If we do create such circuit, machine will be able to learn it. How will it be learning it? We will be giving some historical data, as I said. So we will be giving the value A, value B, and we will be expecting the. So we pass the A and B to the machine, but we do not have these numbers -1, -1, and 2. So these are the weights which the machine will try to fit. Okay, machine will try to learn. So what the machine is learning? Machine is learning these weights, what have to be applied, which factor should be multiplied by what level, so that it can learn. So once we give the historical data, which is like A and B, and we also tells the machine these are the output, the machine puts this into the circuit and tries to learn these weights. Once the weights are learned, okay, let's bring in new input A and new input B, and you will get the corresponding output. That is how the machine learns. And that is where we said that machine is going to learn something, create the code for us. What is the code? The code is basically the equation. The equation saying A into W1 plus B into W2 plus bias, and put it into the function. W1, W2 and bias value are unknown. Those unknowns will be calculated. Those unknowns are the part which machine will learn and put into the equation. Once the equation is there, the code is produced and it will process it. In this learning, we do not tell the machine that how much weight A should have, how much weight B should have. Similarly, when we pass the picture to the machine, we do not tell the machine that you have to focus on the eyes, you have to focus on the lips. Okay? We just gave the machine, okay, and let's machine differentiate between those images, looking at the pixel values, how they're changing between images, and learn which pixel to give how much focus in order to find out finally a result being a boy or a girl. Okay, and that is a classification example that can be applied to boy, girl, or can be applied to defaulter, non-defaulter, good customer, bad customer, a person who is going to take an insurance or not to be taken insurance, a claim will come or claim will not come. Wherever there's yes, no answer, okay, that is classification examples will be in play. Right. So coming to the part of body parts of the data scientist, or when I said that if you wanted to be a data scientist, you wanted to somebody to be a data scientist, what minimum requirements they would be looking for. Okay, so this will be the part where might be interested if you are looking forward for the data science stream. So for a data scientist, there's very important thing that we have to communicate to the business. Okay, the communication of the findings. So the visualization part, how do we visualize the data? Data is in millions, billions, okay, and that builds out reports out of it might be possible, okay, but not as useful. So visualization is very important. There are tools like Tableau, Power BI, or Click, any of the one tool. If you learn about these tools, it will be very helpful for you in terms of transforming the data into the talkative information, okay, like plots. Then we do something like supervised learning. So like examples, we said finding an image, and we're looking at the image of a distinguishing between a girl and a boy. So that is classification. So when we have output where we have to classify something as a girl or a boy, that comes into the classification bucket, and that is supervised learning. We are supervising the machine, giving them that this is the image as an input and this is the output we expect, which is the output is a boy or a girl in the image. So we tell the machine the input and output. Therefore, we are supervising it, and the outputs are either a girl or a boy or something countable. Okay, let's say a digit to be found. So OCR has to be done and a digit has to be found. The digit can be from 0 to 9. So there are 10 options. They are classifying. Okay, so the classification comes into the picture. There can be another example, a kind of a data or the prediction we have to do is about the regression. So regression comes into play where something, a continuous number has to be predicted. Okay, if you wanted to predict what will be the salary of a person after he graduated from this particular college. So the salary is in numbers, continuous numbers. Okay, so that is regression. Regression algorithms related to regression needs to be studied. Then there comes to be a different type of a data which is time dependent. Okay, so salary or a person, like there is a girl or a boy in an image, it doesn't depend on time. Okay, it's not like boy is there in an image and in the same image after 2 months there will be a girl. Okay, so that these classification regression basically covers the time independent predictions. The time dependent would be something like a stock market, okay, or a GDP growth. So these are dependent on time. Okay, today the GDP growth is this. Tomorrow, what will be the GDP growth? Okay, today the stock price is this. Tomorrow, what will be the stock price? So that time series analysis. Okay, so time series being played over there. Then there comes to be a cases where we wanted to do the analysis where we do not have already something to say to say in like terms of like we do not want to classify or predict something. Okay, but we wanted to group that. The grouping, the where we started from saying recommendations. We wanted to associate one customer with another customer. Okay, we wanted to associate or basically segment the customers into multiple groups, so that clustering and association rules, which are part of unsupervised learning, comes into the play. Unsupervised, why? Because we are just going to give machine the list of customers, the attributes of customers, but not what are these customers. Okay, what at the end, are they good customer or bad customer? That is not what we are trying to learn. We are trying to group them. Okay, so that is unsupervised machine learning. We are not giving the output to the machine upper hand. Then there comes a non-traditional data. So this is like supervised, unsupervised can be done. So that can be done on a tabular data. If you've got a tabular data, the data is in the Excel form. Okay, the table you can imagine. Now the data can be a non-traditional data. Okay, something like images or the videos. Okay, how about like YouTube telling you that if you search actor's name, okay, and it will just populate all the videos where the actors have appeared. Okay. So how will that be happening? That there has to be an analysis being done, which is somebody is looking at the videos and finding out these actors are there and then tagging those actors into the video. No, they won't be. Okay, that's not possible because the amount of data being pushed into the system, that it cannot be done by somebody manually. But we can make the videos or the images processed such that the individuals can be found out and tagged automatically, so that when the next time a person searches, the tags are there in the system which can pull the videos, even though the video was not labeled by that person's name, but the person appears into that video, therefore it will be pulled out. The text analytics, like analyzing the Twitter information, not Twitter, Twitter information, or the Facebook. Okay, how about governments or basically a politician coming to a place and then giving a speech? Okay, now he's going to Bihar and giving a speech versus he's going to Mumbai and giving a speech. Will those same, like these two speeches have the same topic in play? How about connecting the audience? Like, look at the people in Bihar talking on the Facebook, what they're talking about, what are their concerns are, hearing the voice of the nation. How does it done? By analyzing the other news portals, that the local news sites, what they're talking about, what people wants to hear. Okay, deliver that. That is based on the text analytics, audio analytics. Okay, you go and like you start talking to Siri. Okay, you start talking to Alexa. How does that work? Okay, it processes your voice. It understands, converts the voice into the text, and then read the text and then process it and gives you the output. So input is a speech and the output is coming out. So how does that transform? So everything, either be a text, image or audio, all of these or will be a non-traditional data that has to be converted into the traditional form. Once it is in traditional form, the role plays of the supervised and supervised machine learnings will come into the play. Right? So processing begins, the backbone of the processing is everything is this one particular neuron. Okay, and then how do you feed the data to the neuron? The cooking part is converting the data into the language which the machine will understand. Okay, prepare the food for it, push it to it. One of the programming language is required, like you don't have to master that language, but if you wanted to be in this field, it would be good for you to have knowledge on one of them. Okay, Excel is if you just like, if you do not want to go into the coding part and want to do it, yes, you can look at the Excel. Excel gives a lot of analytical solutions are already there, so you can use them. But I would suggest, if you are looking for a language or a suggestion from my side, the Python is the go for the industry. Okay, so you can choose Python, R, Scala, SAS or Julia. The Python is the one which is throughout industry being adopted in lots of projects. It's very well evolving, adopted, and very well versed for the machine learning sides also. So go for it. Now coming to the insurance domain case studies. So within the insurance domains, okay, what do we try to find out? So in the insurance, there is something which talks about fraud detection. So we started by talking about classification. Okay, so either fraud is happening or not happening. Okay? Traditionally, it was being done by looking at the individual customers. Okay, what their characteristics are, can they create a fraud or not? Lot of human relationships has to be looked for. Okay, to find out a fraud. But see the importance of fraud. Insurance fraud costs billions of dollars per year across the globe. Okay, making it imperative that insurers take a proactive stance against fraud. Insurance companies should establish a technology frame, tap into advanced automation and analytics, and take steps to prevent it. Okay, so it starts by implementing the foundational framework. What type of data is to be collected, use the data analytics to detect a fraud and continually review the fraud. So using the statistical methods like descriptive statistics, which helps the people to generate the key areas, okay, where the key focus needs to be there for the organization, okay, to control the fraudulent cases. Data analytics empowers insurance industries to detect fraudulent activities, suspicious links and subtle behavior. So the suspicious link is not with one case, okay, links between the cases, like there are billions of cases around the world. Now, how do we link them? Okay, how do we bring them close? Again, coming from the picture where the association is being created. Supervised machine learning using classification technique is used to learn from the historically reported data where the fraud and no fraud have been reported manually. Okay, so it is not that machine will learn something by default also. We have to supervise the machine, as I said. So in most of the cases, something has to start from. Okay, so a data has to be processed manually. Okay, not for billions together, but how about, like, see, you have to process something on a Twitter. So our company hires you and asks you to process like what people are talking about new product. Okay, now how many people will be talking about? Okay, there will be many people. Can somebody read it? No, they will not be able to read it. Now, how do you get the sentiment out of the people? Are people talking positively about the product or negatively about the product? What type of features do the people want in the product? That the new launch which I'm going to provide. Okay, so how is it done is a small set, okay, a sample set is collected. From the sample set, somebody can manually read them and see what the people are talking about, what the senses are, and then label them. Once this input, which is the tweet, and the output, which somebody has labeled it, goes to the machine tries to understand what are the words being used, okay, what is the connection between the statements and the sentiments, and based on that, once the machine has been learned, now there's no limit. Okay, you pass the data to the machine and it will tell you the sentiments. So there the supervised machine learning comes into the play along with the unsupervised versions. This process will not only save money, which is finding out the fraudulent cases for the insurance house, but would also allow them to ease claim process, okay, and the turnaround time. So there used to be a place where the turnaround time for a claim used to be like in months, okay, and in weeks. Now, if you think about who is attracting the customers, okay, who is giving the happy smile to the customers, the ones who is reducing this turnaround time. to a very significant clauses. There are people who are giving who are claiming to give the to process the claim within a day, within few hours. How is it possible? Okay, because the AI is at play. The other use case comes from the price optimization. So within the price optimization, what happens is it's important to identify the statistically important variables. Okay, the variables that forces the price to change. So looking at the insurance policy, the price for the premium which you have to pay. Okay, how does that come? Okay, what variables does forces them to go up or down? Okay, think about it. You go to the insurance website. Okay, you try to fill in your values, and it has been seen from the past. Okay, the insurance the major factor, one of the major factor comes out to be people is smoking or not. Okay, so they ask you upfront, are you smoking or not? Because the price has to be optimized based on it. Okay, if you're not smoking, then there will be a separate section of a price for you. If you're smoking, there will be a separate section of a price for you. So identifying the statistical important variables that forces the price to change is very key important. Insurance company's source of revenue is directly linked to the insurance premium. So if they are not placing it right, they are going to lose the money. Okay, and the factors that links to the pricing are the risk, location, peril, taxation, sanctions, type of business, and lot more factors. And finding the right relationship is the key. By using the data, historical data, those relationships are to be brought down, and then the strategies comes into the play. Looking at the claim prediction. Okay. So imagine if an insurer providers know upfront, because that is a cost to them. Okay, they have earned the money from you. They have taken the money as a premium money. Now they have to pay it back. Okay, so if they know what is the outflow for the claim, if they can predict how much I have to pay back in the next quarter, okay, that is going to be the best pointer for the strategies to claim. Okay, how much money they are going to earn in the next quarter depends on how much claim they have to pay. So the decision in an insurance company heavily depends and is deterministic by accurately predicting the inflow of claim requests. So understanding the claim inflow gives the chance to a chance to reduce the finance losses for the company, because claim is basically the loss, although it's the outflow, but it's the loss to the company. So preserving it is the key. So insurer use rather complex methodologies for this purpose, and the major models in play in the industries for this are the random forest and the boosting models. The great number of different variables are under play for this analysis. Thus, the algorithm involves deduction of relationship between policies and claims. Okay, so what type of information we have got in the policies and how it is related to the claims for the not only for the individual but for the sectorial wise also. So there are a big difference between sectors and the claims coming on to them. So that has to be the part of the analysis. Right. So if you wanted to learn more about it, okay, the one-stop shop for anyone who is enthusiastic and looking for the data science learning would be the Kaggle. Kaggle is Alphabet owned, which is a Google as a parent company, and it provides competitions. Okay, a very well competitions, like most of the famous competition in the past were happened in Kaggle. Okay, be it one of the competition to beat the chess grandmaster, or let's say AlphaGo games being played over there, and then very well real-time data you will find out from multiple universities coming on to it, universities creating competitions and looking for the solutions for the data which they have got. So you will find the data also. So there's lots of data present, and which I said, data is a food for the data scientists, for the machines. There's a lot of food to capture. Okay? So that is the area. They provide you the notebooks. Okay, so there are already written solutions over there for the codes, how the analysis is done at the backend. They are not always technical, very code heavy dependent. They are also in terms of explanation. So a lot of explanation is there. If you wanted to learn on particular subject of your interest, search for it, a data set related to that, and then you will find out the notebooks which are worked on that data set with explanation. Okay, that will be a good pointers for you to begin with. There is a very active community of Kaggle. They are very enthusiastic and they are talkative. Okay, you can post your queries and they will be responding. Okay, you can expect a response from them. It's not going to be closed one-end distribution or one-end communication. Now there are courses also. So if you are looking for something as a specific to understand, they are highlighted notebooks, which are people have written something good about a particular topic. You can go and subscribe to the course. You will find out the notebooks which are related to that course. Okay, and then you can learn from there. So Kaggle is a one-stop shop for anyone you wanted to refer, you wanted to learn. This is the place you go. Right. Any questions before we close?
Good afternoon, sir.
Yes, please go ahead.
MRI or any report will be signed, it will not be taking any intervention for the human. So your mindset is being built up for human beings, and diagnostic report, if it will be signed by a doctor, then only the confidence builds up in the person. If it is not signed by the doctor, it is not seen by the doctor, only a robot is signing on saying that you are COVID positive or you are COVID negative. Users are not getting confidence on that. So how much time will take that this confidence will be built up?
Right. I think an excellent question. This talks about when we are moving towards something as a future. Okay, there's always a friction coming in. Okay, so imagine how much time it took us. Okay, to order something online first. So we have got Amazon from a long time. Okay, it took a lot of friction from the common people to understand. I heard the question, Vikas. So, are you able to hear me, Vikas? I'm answering the Mr. Ashish's question. So the point is the friction is there, but it will take time. I'll see from my experience. What I'm seeing is it will take a couple of years more, but people are moving to a point where they are understanding. Yes, if something is done with backing, the people who are in this industry understands the importance of it, and the general public will do. Okay, the things which I started by saying, there is a disruption. Okay, the Uber company came into the play. People were thinking that they are charging us more. That confidence took some time to take up. Okay, they are charging, they are not charging more. Okay, sometimes they might charge more, but at the end we are getting a better result out of it. So from the medical industry also, the reports will be automatically sent to the people. They will trust it. It might take a year or so, or a couple of years for them to believe, but it's being happening. Okay, people will not. People were having a friction to do online business. Okay, there was a disruption like demonetization or the lockdown, where people started making online money transfers. Okay, so there is a push required from overall ecosystem, but the ecosystems take some friction but changes, and I see that it will be changing sooner. Right, Vikas, please carry on. Right, so I provided my email address and my LinkedIn link for you to communicate. If you have got anything to follow up or discuss, feel free to communicate me through these links. Right. Yes. Mr. Pani, I think you are talking about the density of the data. If the data is too dense on a particular site, which is, let's say, a biased data you have got, so which actually happens in a lot of cases. So if you are looking for something like a fraud, okay, or looking for a person having a cancer, so how many images do you think has been done and actually people have got a cancer? Maybe out of 1,000 people, 5 people will get it, okay, actually have the cancer. So the ratio of the data which we get, okay, sometimes get too biased on a particular class which is not of our favor, because we do not want to find a person has got not a cancer. We wanted to, okay, if a person is going to create a fraud, that is what we wanted to highlight. There are billions of transaction happening, online money transfer happening. Out of billion, do you think more than few thousands are actually fraudulent? No, they are not. So credit card expenditure, that the data when collected shows that in reality, okay, in population means the whole of the data, actually there is a bias between the data. So for that, there are techniques to make sure when we feed the data to the machine do not focuses on the majority cases. Because see, if I always go with the analogy of teaching my child, okay, if I always show boys to my child, now how will he know what the girls look like, right? So I have to tell, okay, maybe even though I do not have lot of girls images, okay, I will show the same image again and again, okay, a slightly difference. I'll just make the color change, okay, or maybe I'll change a few filters, I apply a few filters on the image, and I show the same girl image, but by applying the filters, so that his attention is not only on the boys, or to differentiate with the boys. So same thing happens with a person, like a fraudulent transaction versus a good transaction. So there are a lot of good transactions, but there are few fraudulent transactions. We pushes or we fine tunes those fraudulent transactions a little bit more, so that the machine do not focuses on good transaction. We wanted the machine to learn fraudulent, because that is the key objective of learning as well. So that is how we played. There are a few techniques called SMOTE. Synthetic data has been created for it, which you might find out to search. SMOTE it is called SMOTE. Right. Any other question, Vikas? Right. So basically, the fitting of a model, okay, the fitting of a model is to be stable. As you have already said that this is the problem. Okay, you understand that if the model is not good fit, okay, it might fit. By fit, I mean the model is doing good for a particular data set and not doing good for the other data set. Then this is not a stable model. Okay, it has basically got some features which is overfitting, which is called as overfitting. Means when I showed few images to the machine has overlearned those images. If I show exactly similar image or a image which is closer to the past images which I've shown to the machine, it will depict it properly. It will find it out properly, classify properly. But how about a completely different image? Okay, an image which it has not seen before, okay, which is not very close to the one, it fails over there. So why it has failed? Because the data which we have used for learning is not good enough for the machine to generalize the things. So whenever you find out a machine is doing overfitting, okay, there are few pointers about fine tuning the model, but that will be applicable up till a limit. Okay, look for those fine tuning. If the fine tuning is able to perform, make your model stable, test the model on multiple occasions, do multiple cross validations, find out if it is stable. If it is not stable, right, try to bring in more data and then retrain it, because the data which you have got certain characteristics which is very pertaining to that particular data set. So the sample data which we use to push into the machine should not be very particular to a particular objective. Okay, so it has to be generalized itself. It should be a good sample of a population, a good representation of a population. Sometimes we have to bring in more data, or sometimes we have to drop certain type of data to make the sample be an equivalent to a population. Right, Vikas. Any other question? I would need to understand what is alternate technology means. The data science is about algorithms. So data science is about the algorithms. When I say it is, sorry, if I go to the presentation back, when I talked about over here classification, regression, time series. Okay, so data science is about classifying. Now, how do you classify? There are multiple algorithms for it. Not one, not two, but there are many. And this is a science field. Okay, so scientists are evolving. So new and new algorithms you might see in future coming up. So there are algorithms which are pertaining. Now, how do you implement those algorithms? By which language you apply, which technology you use, that doesn't matter. The core concept is what algorithm fits to your data, fits to your business. When we talk about this perceptron, there are, as I said, this is one cell. Okay, you imagine one transistor. I have given you one transistor, and then you have to create a complete network of it. Okay, you see a whole grid has to be created from one particular cell. How do you create a grid? You can create lot of combinations out of it, right? Similarly, this particular one cell can be fit into multiple positions and can be brought into a bigger circuit to learn anything. So the root is the cell and the algorithm. Right. Anything else, Vikas? Thank you, Vikas, for actually calling me. And as you just said that at the end people are asking questions, the interaction was there. This is the learning. Okay, this is historically we have seen people when interact gives the feedback good at it. So fully people have learned something. They wanted to get in touch with me. There is the email ID and the LinkedIn ID. You can get in touch with me later on. Thank you so much. Good. That's good. Thank you, Vikas.
Thank you, sir.